Hello, am I audible? Hello,
Yes, sir. We can see it.
oh, thank you. So today's topic is based on the biotelemetry. So what is biotelemetry? Now, biotelemetry, or as it is called the biomedical telemetry, that is the measurement of biological parameters over distance and transmitting the data from one point of generation to the another point of reception. Okay, so radiotelemetry, that is the process in which the biological data, different biological parameters that can be used to modulate a radio frequency carrier so as to be radiated by the electromagnetic field, which is called the radio transmission. Now, there are many applications in which it is necessary to monitor these physiological events from a distance. So typical applications are like this: radio frequency transmission for monitoring of astronauts in space, that is the application, one application of biotelemetry. Second is the patient monitoring, where freedom of movement is desired, such as in obtaining the exercise electrocardiogram. Okay, so in this application, the requirement of trailing wires is both that that is very dangerous. Okay, patient third is the patient monitoring in ambulance and in other locations away from the hospital. Fourth is the collection of medical data from home or from office. Fifth application, where the research on unrestrained or anesthetized animals in their natural habitat, that can be monitored. Next is the use of telephone links for transmission of electrocardiograms or other medical data. Number seven, that is the special internal techniques such as tracing acidity or pressure through the gastrointestinal tract. Then next is the isolation of an electrically susceptible patient from power line operated HDCG equipment, and this one is to protect him from accidental shock. So these are the typical applications in biotelemetry, and these applications have indicated the need for system that can adapt existing methods of measuring the physiological uh, different physiological variables to a method of transmission of that resulting data, and this is called actually the biotelemetry. So the biotelemetry, so physiological parameters, these those are adaptable to biotelemetry. It is categorized into two, that is bioelectrical variables such as ECG, such as EMG or EEG, and here the signal which is obtained, that is directly in electrical form. Second category, where the physiological variables that require the transducers such as blood pressure, gastrointestinal uh, pressure, uh, blood flow, and temperature. So it requires the actually excitation, because the physiological parameters, these are measured as variations of resistance, variation of inductance or capacitance. Now the biological signals or biosignals that can be telemetered, so it is used in ECG telemetry, it is used in EMG, as well as in EEG telemetry. So in ECG telemetry, what happened? This is the most widespread use of biotelemetry for bioelectric potential, as in the transmission of ECG and different. So instrumentation at the transmitting end is simple because only electrodes and amplifications are needed here. And so, for example, the ECG telemetry. So transmission of ECGs from an ambulance or site of emergency to a hospital. So a cardiologist in the hospital immediately interprets the ECG, instructs emergency uh, resuscitation process and to the trained rescue team, and arranges for any special treatment that is necessary on arrival of the patient at the hospital. Now the telemetry that is also supplemented by two-way voice communication. Okay, another is the, like for exercise, different ECGs in the hospital so that the patient can run up and down steps. So there is also number three, like the individuals with heart problems that can wear the ECG telemetry units always and rely ECG data, which is really over the uh, telemetry channel. So this ECG data periodically given to the hospital for checking. And next is to monitor the athletes running a race for improving their performance, that can be also used here. Human performance laboratories in college campuses use this telemetry system, ECG telemetry system. So the actual equipment that is worn by the subject, is the patient, which is very comfortable and usually does not uh, impede the movement, since the electrodes are taped into place and the patient wears a belt around the waist with a pocket for the uh, transmitter. Now this transmitter is about very small size. Okay, and the wire antenna that is incorporated in the belt, that is, or it is hung loosely. So the clothing has opening to allow the lead wires from the electrodes to come through the transmitter. And the power for that transmitter, this is from a battery, usually a mercury cell is used with useful life of about more than nearly about the 30 hours. And for cardiovascular research performed with experimental animals, these electrodes are needle type electrodes. These are used and animal interfere with the equipment. So that's it. The miniature transmitters are surgically implanted here in this position. Next, for the easy telemetry. So here the EEG electrodes are implanted in the brain of the chimpanzees in the space biology program in the uh, one laboratory which is situated at Los Angeles. Now, a small transmitter which is to be installed on the animal's head transmits the EEG, and sometimes instead of these special uh, helmets with surface electrodes are used. Second type of is EEG telemetry is the special helmets with surface electrodes are also used for collection of EEGs of football players during uh, the game. Third is for study of mentally disturbed children. The child wears specially designed football helmet or spaceman's helmet with built-in electrodes so that the EEG that can be monitored without the traumatic difficulties during the playtimes. Next is EMG telemetry type, where the bioelectrical signals that can be telemetered, and this is called the electromyogram telemetry, EMG, and it is used for studies of muscle damage and partial paralysis. problems and human performance studies. Now there is called one is drop foot. So drop foot, that is one disease. Basically, uh, it is most common disabilities which is resulting from stroke. This condition is essentially an inability to the patient to lift his or her foot, which results in a uh, shuffling or toe dragging gait. So method for this correcting this drop foot by transmitting a signal to an implanted electronic simulator, which has been used uh, successfully in one laboratory where that is situated in Los Angeles. And in that process, what happened, an external transmitter which is to be owned by the patient, which delivers a pulse modulated carrier signal of some kilohertz to an implanted receiver that demodulates that signal, and it delivers the resulting signal to the personal. uh, so it is mm, it's a train of pulse is to be given, and the pulse duration of some microsecond, like 300 microsecond pulse is to be given, and the frequency that can be varied uh, between the 20 to 50 pulses per second, which is to be given to the uh, peroneal nerve. Now, this nerve, when it is stimulated, it causes the muscles in the lower forepart of the leg to contract, and, uh, and after that, it raising the foot. Now, stimulation is automatically cycled during this process by hill switch that turns the transmitter on and off so as to approximate the normal uh, activity of these muscles during this gait operation. Now, by using suitable transducers, telemetry that can be employed for the measurement of wide variety of physiological variables can be incorporated. In some cases, what happened, the transducer circuit, which is designed as a separate plug-in module to fit into the transmitter, that allows one transmitter design to be used for different types of measurements. Okay, and also many uh, variables that can be measured and transmitted simultaneously by multiplexing the different techniques. Then physiological variables that also that can be measured using the uh, telemetry. So the transducer circuit actually that is to be used for different measurement, like skin or systemic body temperature by rectal or oral thermistor, and respiration by impedance pneumograph. Third can be indirect blood pressure by contact microphone and the cuff as well. Fourth can be measurement of blood pressure and heart rate research in um, anesthetized animals. Here, the transducers are surgically implanted with leads brought out through the animal's skin, and a male plug attached to the leads that is to be connected uh, to the female socket content in the transmitting unit. Next, blood flow measurement using a Doppler type and electromagnetic type transducer is there, and next can be monitoring of visual and temperature of for long-term studies of natural birth control in obstetrics and gynecology. Next can be use of radio pills for monitoring the stomach pressure or the pH measurement inside our body. So these are the different physical variables that can be measured using this biotelemetry system. So next is the components of a biotelemetry system, where you can see here on the left hand side there is a biotelemetry transmitting system, and on the right hand side this is the biotelemetry receiver system. So a radio frequency carrier, that is a high frequency sinusoidal signal which is propagated in the form of electromagnetic wave when applied to an appropriate transmitting antenna. This The range of this system is the actually that is the distance for which the transmitted signal that can be received, and it depends on the power as well as the frequency of the transmitter. Also it depends on the relative locations of the transmitting and receiving antennas and the sensitivity of the receiver. Now here two terms you must familiar with, that is one modulation and it is demodulation. So modulation is the process of impressing the information that is to be transmitted on a carrier signal. Okay, so in continuous wave transmission, what happens, the transmitter is simply turned on and off to corresponding to some code. Now, this cannot be used for transmission of physiological data, but it is useful for remote control applications. Okay, so physiological so in the receiver, in this receiver, it consists of a tuner circuit to that is used to select the transmitting frequency, and a demodulator, to separate the signal from the carrier wave, and a means of mm, displaying or recording uh, the signal. This signal that can also be stored in the modulated state by the use of tape recorder, mm, where it is shown this one. And since most biotelemetry systems involves the use of radio transmission, so it is very important to use the radio frequency signal as a carrier signal. And the function of this demodulation or demodulator, that is the equipment which is basically capable of receiving the transmitted signal, and again it is converted to recover the information that is comprised the receiver. By tuning this receiver, the frequency of the desired um, radio frequency carrier, that signal can be selected, uh, while some of the uh, signals are rejected. Okay. Now there are two basic systems of modulation has been given here, that is the amplitude modulation and the frequency modulation. Okay, so in an amplitude modulation, the the amplitude of the carrier, so this is one signal, this is the carrier signal, where the amplitude of the mm, carrier that is varied according to the information which is being transmitted, and it is used in standard radio broadcaster unit stations and video signal for TV, and it is more susceptible to natural and man-made electrical interference because the interferences generally appear as vibrations in the amplitude of the signals. Okay, so next is the FM signal, frequency modulation signal, where the frequency of the carrier is it is varied according to the mm, information which is being transmitted. Okay, so in this way, so here the frequency is maximum, here this is the minimum, then again maximum, so it depends on this one, and is carrier wave. This is the uh, is input signal and this is the carrier wave signal. So when it is applied to the FM transmitter, the frequencies are very less over there and here the frequencies are very high. So in this way the frequency modulation signal is generated. Okay, so it is this FM actually, it is used in FM broadcasting stations as well as sound signals for TV. So it is less susceptible to interference because the variations in the amplitude of the received signal which is caused by the interference that can be removed at the receiver before demodulation. Okay, and hence the FM transmission is used for telemetry purpose. FM method consumes more energy than any other technique which is called the pulse modulation technique. Okay. So the biotelemetry system uses two modulators. The physiological signals are used to modulate a low frequency carrier which is called the subcarrier in the audio frequency range. And the radio frequency carrier is then modulated by subcarrier and transmitted. And the double modulation which gives the better interference free performance in transmission and enables the reception of low frequency biological signals. And the sub modulator that can be FM or pulse width modulation, but the final modulator is practically always the frequency modulation system. Now, if several physiological signals are to be transmitted simultaneously, each signal is placed on a subcarrier of a different frequency using either frequency modulation or using the amplitude modulation technique. And then the subcarriers are added together to give a composite signal in which none of the parts overlap in the frequency. Okay, the composite signal modulates the RF carrier by the same or different method. And this process of transmitting many channels of data on a single radio frequency carrier, which is actually called frequency division multiplexing technique. And this is more efficient and less expensive than employing a separate transmitter for each channel. And here at the receiver side, a multiplexed RF carrier is first demodulated to recover each of the separate subcarriers, which are then demodulated to retrieve the original physiological signals. Now, both uh, FM-AM and FM-FM systems are used in biotelemetry, and the modulation system, which is selected based on the size, based on the complexity and the noise transmission and other operational problems that can be used uh, in the in this type of modulation system. On the right hand side you can see it pulse modulation technique, a pulse modulation system where the carrier is a series of short pulses. Now in uh, pulse amplitude modulation, the amplitude of the pulse is varied according to the transmitted information, whereas in PWM, pulse width modulation, the width of the pulse is varied according to the transmitted information. Okay, there is also one technique which is called the PPM, pulse, uh, that is one type of pulse modulation where the timing of a very narrow pulse is varied with respect to the reference pulse. And most pulse modulated telemetry system as a subcarrier as well as the radio frequency carriers to achieve better stability and greater accuracy. So in PIM technique, the pulse interval modulation technique, the length of the interval between successive pulses T1 is which is always proportional to the signal input, and this system is best suited to bipotential or accelerometer usage, but may be used for the temperature as well. And in the PIRM technique, pulse interval radio modulation technique, where the ratio of two successive intervals in each sequential pair of pulses is proportional to a function of the signal input. And this system is more complex than the pulse interval modulation technique, but is less dependent on uh, the battery voltage. Okay, it is best suited for applications such as the temperature and the pressure. So next is the blood pressure telemetry. So here in this on the left hand side, that is a system for monitoring the blood pressure. It's a method of transmission, and here the transducer used in this case is the flash diaphragm type of strain gauge transducer, uh, and electrically it can be represented by this bridge circuit. Okay, and in this circuit the registers R1 and R3, these R1 and R3, R1 and R3, these will be decreases, whereas R2 and R4, these are to be increased in value as blood pressure increases. And register RB here, that is simply for balancing or zeroing this circuit. On the right hand side, this is one type of exciter transmitter unit for blood pressure telemetry system.
Sir, RB and R2 are not connected.
Yes, yes, connected.
Hello?
Yes, connected.
RB and R2.
Connected. This one is connected. This one. Okay. There is a printing mistake.
Okay, sir. Okay, sir.
So it is one type of exciter transmitter circuit. So here the Colpitts transistor oscillator circuit is used, and RC coupled C amplifier stage circuit is used. So it basically this exciter excites a flash diaphragm type of strain gauge transducer bridge, which with a constant AC voltage of frequency 5 kilohertz inductively. So the bridge is balanced so that any change in resistance of the bridge due to the changes in the pressure on the transducer, it changes the output voltage, and this output voltage is coupled inductively uh, to an amplifier. And so the output of this class C amplifier, here it is used class C amplifier, and this class C amplifier output is to be rectified and filtered and given to a FM subcarrier oscillator circuit for controlling the frequency of the uh, audio subcarrier. Okay. Now the subcarrier frequency range, which is to be approximately 1 to 2 kilohertz, which represents the range from 0 to 300 millimeter of mercury. So that is the pressure which is to be uh, measured. And the modulated subcarrier is then used to frequency modulate the main radio frequency carrier, and the carrier is transmitted at very low power on a frequency band specially designated as in biotelemetry system. Now the transmitted signal is picked up by the receiver, and the subcarrier that is to be removed from the radio frequency carrier and then demodulated to obtain the original data waveform, and then this signal is displayed on a or recorded on a chart. Okay, so that is the blood pressure telemetry system. Now here this is the PWM telemetry system. On the left hand side it is the bilink PWM transmitting system, and on the right hand side it is the receiving system. Okay, so this is the transmitter, this is the receiver. Now it transmits 4 channels. In case of transmitter, it transmits the 4 channels of physiological data simultaneously. The sync pulse here, it turns on the first channel, the ring modulator or one-shot multi vibrator circuit, and it remains on for a time period of T1, assume. That is based on the level of physiological data which is fed into it at that instant of time, so that its output pulse which has time period of T1. So when the multi vibrator is turned off, then it triggers the second channel multi vibrator, and so on down the line. And the output of these 4 multivibrators are uh, square signal pulses of time periods T1 to T4. Okay, and the position of each pulse with respect to its neighbor, that is proportional to the corresponding physiological data. Okay, the mixing network here, it differentiates the square pulses and clips the positive part to obtain the negative pulses, and forms a composite signal of positive synchronizing pulse and a series of negative signal pulses. And the FM transmitter, this FM transmitter, it transmits that composite signal after generating from this mixing network. So that is the transmitter circuit function, and on the right hand side it is the receiving system or receiver, where the signal, the synchronizing and the signal pulses are to be separated. So here what happened, synchronizing pulse is sent only to the first channel flip-flop, while the signal pulse that are sent to all channels flip-flops. Now the synchronizing pulse turns on the first flip-flop, and the first signal pulse turns off the first flip-flop. And here the width of the square wave output of the first flip-flop is same with the width of the first signal pulse. Now the second flip-flop is turned on when the first flip-flop is off, and is turned off by the subsequent signal pulses, and so on. It goes to down this line one by one. Now the width of the square wave output of each of the 4 flip-flop is equal to that of the corresponding signal pulse, and the square wave outputs are then integrated to obtain the 4 physiological data. So that is the receiver function of this PWM telemetry system. Now move on to the next slide, where the single channel telemetry system is considered. On the left hand side it is the telemetry, it is the transmitter section, and this is the receiver section. Okay, so for ECG telemetry purpose, this is the single channel. So there are 2 types of the single channel and multi channel. So first, this is the single channel telemetry system, where only one parameter is to be telemetered, and commonly telemeter parameters using this single channel telemetry, one of this ECG, and that is the temperature. So in case of ECG telemetry system, uh, ECG and cardiac output that gives sufficient information about the cardiovascular system. And two main parts are there, that is the ECG transmitter and ECG receiver. Okay, so under ECG transmitter, so ECG amplifier is there, subcarrier oscillator is there, ultra high frequency transmitter is available, and dry cell batteries are available. Under receiver system, high frequency unit is there, demodulator must be there, and electrocardiograph or cardioscope will be there, magnetic tape recorder, and the heart rate monitor will be used in the receiving section. Now, different requirements are available for distortion-free transmission of ECG, like okay, so to get the distortion-free ECG transmission, so there are some requirements, like the patient should be able to carry out normal activities with very comfort level. Motion artifacts and muscle potential interference, that should be minimum as possible. Battery life should be long, and the amplitude of the pacemaker pulse, that can be as large as 80 millivolt. And some ECG system which operates at uh, 450 to 470 megahertz band, which is uh, well suited for hospital transmission and can accommodate the large number of channels. So for transmitter circuit, certain requirements are there, like the ECG signals that picked up the three pre-gelled electrodes, that is amplified and used to modulate the 1 kilohertz subcarrier frequencies, that in turn frequency modulates the ultra high frequency carrier signal. The resulting signal radiated by electrode lead right leg, that serves as the antenna, as you can see here in this picture, this one. Then input here, uh, input circuit be protected against large amplitude due to fibrillation technique, and this input amplifier is must be AC coupled to that subsequent or successive stages. Now, coupling capacitors are needed to eliminate the DC voltage and determines the low frequency cutoff of the system, as usually, uh, which is like 0.4 hertz range. Subcarrier oscillator must be there, uh, where the current control multivibrator circuit can be used to provide the some deviation of this signal. And subcarrier filter also must be there to remove the square wave harmonics, which results in a sinusoid for modulating that particular carrier signal. Okay, and crystal control oscillator circuits must be there, which generates carrier at some 115 megahertz signal frequency. And class C transistor doubler circuit can be used over there. Output power should be maintained at 2 milliwatt, and the operating, it must be 2 milliwatt approximately. On the receiver side, there must be an antenna, which is an omnidirectional antenna, quarter wave monopole, that is to be mounted vertically over the ground plane of the receiver top cover, and it works well to pick up the randomly polarized signals. RF amplifier should be there, It provides low noise figure, RF filtering, and image frequency rejection uh, must be there in the RF amplifier circuit. Then local oscillator circuit is there. It basically 115 megahertz, which is to be multiplied by 4. Multiplier circuit can be used, and tuned amplifier must be incorporated here. It needs the mixer, which uses the square law characteristics of FIT to avoid the interference problems due to the third order intermodulation. Crystal filter is there. It is an 8-pole filter with 10 kilohertz bandwidth, which determines the receiver selectivity. And also it provides the 60 decibel of rejection for signals 13 kilohertz from the central frequency. IF amplifier is there, which provides the requisite gain and operates and automatic gate control amplifier that reduces the mixer gain under strong signal conditions to avoid the overloading. Discriminator circuit is there, must be there to the output of that discriminator circuit is 1 kilohertz subcarrier that is averaged and fed back to the oscillator for automatic frequency control. Okay, or AFC in short, it's called AFC. Demodulator circuit must be there. The 1 kilohertz subcarrier uh, demodulated to convert this frequency to voltage to recover the original ECG waveform. There must be demodulator circuit, as well as the low pass filter must be incorporated into this circuit, because it passed through a low filter having a cutoff frequency of 50 hertz and then given to the monitoring instrument. And here the commonly used frequency range, that is to be 174 to 185 megahertz frequency, with the output limited to the 150 microvolt per meter at a distance of 30 meter. And special arrangement should be there, like the low transmitter battery and the NARS call facility must be there. Now, in both cases, a fixed frequency signal that is generated that causes the deviation of the subcarrier signal, which, when received at the receiver, it actuates the appropriate circuitry for visual indications. And that's why their out of range indication circuit must be there, where the RF carrier signal is to be monitored continuously, and when it is out of range, so it gives some alarm um, when this level fall below certain limit. So this is the ECG telemetry system through the single channel telemetry configuration. So in multi-channel telemetry system, now medical measuring problems often involve the simultaneous transmission of several parameters. For, for this type of application, a multi-channel telemetry system is employed. And in this system, what it is particularly useful in athletic training program, as it offers the possibility of simultaneously serving several physiological parameters of the person that is being monitored. Now, with appropriate pre-amplifiers, the multi-channel systems which permit the transmission of the different parameters simultaneously, depending upon the number of channels required, ECG and heart rate, the respiration rate, the temperature, intravascular and intracardiac blood pressure that can be monitored. Now, in multi-channel uh, telemetry, the number of subcarriers used are the same as
Sir,
the.
sir,
Yes,
here, what is the work of A2 and A3, sir?
I will discuss it. So what I am telling. Hmm. So here the number of subcarriers used um, are the same as the number of signal which is to be transmitted. Now each channel therefore has its own modulator circuit, like the RF unit, the same for all channels, which converts the mixed frequencies into the transmission band, and similarly the receiver unit contains the RF unit and one demodulator for each channel. Now here the pulse width modulation technique is better suited for uh, this type of multi-channel uh, biotelemetry system, and such systems are very insensitive to carrier frequency shifts and have high noise immunity. Okay, and so the FM system, frequency modulation FM system, for similar type of use, they may have low power consumption and high baseline stability, but they are more complicated and turn out to be more expensive. They can be uh, troubled by interference between different channels. Okay, and the techniques for separation usually require expensive and complex filters, and even with these the crosstalk can still be a problem. Since the FM system is employed a separate subcarrier frequency for each data channel, it generally involves a high cost. Similarly, pulse position amplitude modulation, which is called the PPM, that is easily gets into synchronization difficulties caused by the noise, and it results in a loss of the information transmitted. On the other hand, the advantage of pulse duration modulation, which includes the lower sensitivity to temperature and battery voltage changes, and its adaptability to that miniaturization due to availability of suitable integrated circuits. Now, for multi-channel radio telemetry, various channels of information are combined into a single channel, and this technique is called the multiplexing technique. And there are two methods. One is called the frequency division multiplexing, another is the time division multiplexing. Now in frequency division multiplexing, the method makes use of this continuous wave subcarrier frequencies, and these signal frequency modulated multiple subcarrier oscillators, each being at such a frequency that is modulated signal that does not overlap the frequency spectra of the other modulated signals. In time division multiplexing, where multiple signals are applied to a commutator circuit, and this circuit basically is an electronic switch that rapidly scans the signals from different channels, and an oscillator uh, is used to drive this commutator circuit so that it samples each signal for an instant of time, thereby giving a pulse train sequence corresponding to input signals. Okay, so here in this diagram you can see the telemetry of ECG and respiration. So an FM modulated radio telemetry transmitter is used to detect and transmitting the ECG and respiration activity simultaneously on a single carrier frequency in the FM broadcast band. Now, respiration is detected by the impedance demographic principle, by which by using the same pair of uh, electrodes that are used for the ECG. Now, a 10 kilohertz sinusoidal constant current is injected through electrodes E1 and E2. There must be two electrodes which must be attached across the subject's thoracic cavity. Now, the carrier signals, which is generated by a phase shift oscillator, this varying the thoracic impedance associated with the respiration, which is produced by it's an uh, AC voltage whose amplitude varies with a change in impedance. Now the amplitude varying carrier is amplified by an amplifier A1, and amplifier filter A3 that recovers the respiration signal by using rectifiers and a double pole filter. The ECG signal, which is detected by the electrodes E1 and E2, it is amplified in the A1 along with the respiratory signal. It is passed through a low pass band Butterworth filter here in this A2, in this section, which passes the ECG signal but blocks the respiratory signal. Now the amplified ECG signal is then summed up with the pre-processed respiration signal in A4 here, and the output of A4, that is a composite signal which is supplied to a stable multi-vibrator uh, circuit which acts as a voltage control sub carrier oscillator. Okay, and actually the sensitivity of this subcarrier modulation system, which is like 650 hertz per millivolt for the ECG signal, and 40 hertz per watt change in the case of a respiration signal when the total thoracic impedance is between 600 to 800 watt. The output of this subcarrier oscillator is then fed to a RF oscillator for transmission purpose. And the circuit requires less than 185 milliampere from a Mercury battery. The signals that can be transmitted over distances up to 15 meter for about 4 weeks before replacing the battery. So this is the telemetry of ECG and respiration using the multi-channel configuration. So here these are some implantable units or implantable telemetry system. So the first one, which is the transducer, which is implanted in aorta. Basically what happened, there are um, there are some application where the transducers in animal research, including the implementation of both ventricles of the heart, the aorta, and the carotid artery and the femoral artery. So in addition to the different blood pressure measurement, we need to use it to measure the abdominal or esophageal, thoracic, or the intracranial pressures also. Now to implant a transducer in an artery, what I mean, the longitudinal incision is made. The transducer is inserted with its housing in um, intimate contact with the arterial wall, and the wound is closed with interrupted sutures. Okay, for cardiac implants, a stab wound in the ventricle permits the ready insertion with the transducer placed free of both the myocardium and the chordae tendon. Okay, so there is a technique basically where uh, the blood pressure in the aorta is to um, that is to be measured by inserting the transducer from the opposite side, and use a small intercostal artery to bring the wire through. Now this creates actually stronger binding active animals. So here you can see it from this picture that the uh, plug was inserted into a biotelemetry transmitter, into a biotelemetry transmitter, so that the blood pressure data could be received remotely. And the use of these transducers and and telemetry have been useful in gathering the information on exercise, the effect of drugs, and extreme, which is used in extreme environments, and the acceleration and impact, different uh, impact studies. Okay. The second is the figure number B, which is the single channel blood pressure transmitter, one type of single channel blood pressure transmitter. So the module that top at the top contains the signal conditioning circuitry and RF transmitter, and the second module contains the uh, 200 milliampere hour lithium power source and a 1.7 megahertz RF switch for turning the system on and off remotely. Okay, and the pressure transducer, which is shown in the lower left corner, uh, that is used with it. And this is the cutaway view of a single channel temperature transmitter, and a 1.35 volt battery is contained inside the antenna loop at the top, inside one of the three hybrid packages is shown here, that is open here. Next, that is the figure where an array of all parts of the complete system, um, implantable telemetry system, is there. The top unit in this figure is the telemetry demodulator, and it has six main channels and is designed to work with some receiver, which is given below of this one. And the receiver that is modified to accept both continuous FM and pulsed radio frequency mode telemetry signal, and inductive power control uh, system is to be attached here for turning the implant on and off, that is shown on the bottom right side. Okay, so these are some implantable units figure. So there are certain advantages and disadvantages of implantable units. There, like advantages is it allows the measurement of physiological variables over long periods of time without any attachment of wires or sensors on body surface. And disadvantages are like the transmitters have to be made as small as possible. At the same time, they must be reliable, and this is possible by using transmitters in thin film circuits. Okay. Second, the weight and size of the batteries must be minimal, and operating life must be maximal, because the energy consumption is minimized by using the micro power operational amplifiers and CMOS components for multiplexing, tuning, and switching operations in multi-channel telemetry systems. Okay, by reducing the transmitter energy consumption and turning on the transmitter only when it is required. Third is the risk which is associated with the surgeon. Fourth is once the unit is implanted, it cannot be serviced, and the life of that unit depends on how long the battery can supply the necessary current. Number fifth is the distance of signal transmission, which is restricted because the body fluids and skin attenuate this signal, and the unit as low power as it is small. So this is avoided by picking the signal with a nearby antenna and retransmitting it. Sixth is the leakage of uh, um, body fluids into equipment or chemical effects of the equipment on body tissue. This results in malfunction or injection the respected. Hence, the outer case and wearing that must be impervious to the body fluids and moisture. Now, this is achieved using plastic uh, coating compounds, plastic material, and silicon encapsulation. Okay. Now, the applications of telemetry in patient care. So, basically, telemetry of ECGs from extended coronary care patients at their it is used for observing the rhythm disturbances of cardiac patients for a period of time uh, following intensive coronary care. Now, each patient has ECG electrode taped securely to his chest. The electrodes are connected to a small transmitter unit fastened to a special belt wound around the patient's waist. Now, the batteries are also included in the transmitter package. The area in which the patient are allowed to move must be limited because the location of the patient cannot be identified. If the patient moves beyond the range of the system, his ECG cannot be monitored. Second is telemetry for ECG measurements during exercise. And this can be used for patient monitoring where free movement is desired. For example, while obtaining ECG while the patient is exercising on a treadmill or a set of steps for diagnosis of cardiac abnormalities such as um, ischemic coronary artery disease. So if WAD connection is used, they may interfere with the performance of the patient. The transmitter unit that can be used for this purpose is similar to that of the extended coronary care, and the receiver and other equipments uh, uh, for conditioning and the playing the signal received from the exercising uh, the patient are located very near the patient. Thus, the transmitter can operate with very low power. So where the electrodes and all wires that must be securely fastened to the patient to prevent their movement because it results in artifacts of the ECG tracing. Third is the telemetry for emergency patient monitoring, where the patient the patient monitoring and collection of medical data in ambulance, emergency side and locations, example office or home away from which is from uh, very away from the hospital and transmitting them to a hospital. So a cardiologist in that hospital immediately interprets the ECG, instructs emergency resuscitation procedures on the to the trained rescue team and arranges for any special treatment that is necessary on arrival of the patient at that at the hospital. So the telemetry that is also supplemented by two-way voice communication to provide the instructions for treatment, example defibrillation, and hence the treatment can begin before the patient arrives at the hospital. So previously described here uh, the transmitter which are used for this application that must be powerful uh, than the applications which are described earlier, because uh, the data that must be transmitted many miles or from a moving vehicle. Also, they must be capable of reliable reception and reproduction of transmitted signals regardless of the conditions. So if the emergency team is working in location where it is not possible to maintain that direct communication with the hospital, retransmission is used. And here the physiological information that is transmitted from a portable transmitter to a receiver in their vehicle. And the vehicle which has more powerful transmitter and better antenna system, it retransmits the data to the hospital. The number fourth is for monitoring the astronauts in space, as I have told you earlier. Number fifth is research on unrestrained anesthetized animals in their natural habitat. Number six, that is for special internal techniques such as reducing acidity or pressure through the uh, gastrointestinal tract. So all these are another if the physiological signals that can be obtained from swimmers, rider, or athletes, or pilots, or manual laborers that can be transmitted over this telemetry channel. So these are the applications of telemetry system in patient care. And so that's all for today. And that is the whole syllabus I have covered for biomedical instrumentation.